integration area under a curve, type 5 continuous piece. So this is a special case of above and below the x-axis, where we have a curve and a line enclosing an area that ends up above the x-axis and below the x-axis, but it is in one continuous piece. So if we've looked at an example of what we've done before with above and below, we can see that we ended up with this kind of a shape. So it's not a continuous piece because we have this N shape above the x-axis separated then by a U shape under the x-axis. Whereas in this case, we have this continuous piece going above and below the x-axis. So when you get that kind of a shape where the line and the curve make a continuous piece, then rather than having to find the limits, let me just mark them in. So rather than having to find the area under the line and the area between the curve and then subtracting, and then the area of the line and then the area of the curve between these limits and subtracting, we end up with a whole big messy kind of question when we have to break it down into lots of different parts. So rather than breaking it down into the bits above and below the x-axis and then adding them all on, all we have to do is get our limits, which is the points of intersection of the of the curve and the line, I should say, sorry. And then we just integrate between those limits. One simple go. So in other words, we would get the area under the curve between the limits minus the area under the line between the limits and subtract the two. Okay, so first thing we need to note is that we don't know what the limits are. So we're going to take the two equations, the curve and the line, and we're going to equate them. So we're going to equate 1 and 2, and that'll find our limits. So we have 4 minus x squared is equal to 2. Oh, sorry, actually, let me go back there. I can't equate them just yet. So I have to take the line and the curve and write them in terms of y. So this one just needs to be written as y is equal to 1 minus 2x. Apologies there. So we're now going to take the two equations, we're going to equate them. So that's 4 minus x squared equals 1 minus 2x. So if I bring everything to one side, I have x squared minus 2x minus 3 equals 0. Factors that multiply to give us minus 3 and add to give us minus 2 must be minus 3 plus 1. If I sub back in, I get x squared minus 3x plus x minus 3 equals 0. To get x as being common, and we end up with x minus 3 is common, x plus 1 is equal to 0, which gives me x minus 3 equals 0. In other words, x equals 3, or x plus 1 equals 0, so x equals minus 1. So if I mark that in on my diagram, that's 3 and that's minus 1. Okay, so what we're going to do is we're going to take that and we're going to get the area under the curve between 3 and minus 1 and the area under the line between 3 and minus 1, and the bits basically cancel out. So the bit under the curve and the bit above the curve and the white bits that are missing here, they all end up cancelling each other out, and we end up with just one simple, straightforward question. But as I said, you can check this out yourself by breaking the curve into the various different parts and adding them on to check, does it give you the same answer if you wish. So the area of the shaded region is going to be area under curve, because the curve is above the line, minus area under line. So I'm going to do curve first. So I'll call that area 1. So for the curve, it's 3 minus 1 between 4 minus x squared dx. So if I integrate there, I get 4x minus x cubed over 3. 3 and minus 1. and then sub in for my 3. And then sub in my lower limit, which is -1. And then that gives me 12 minus 27 over 3 is -9. And then we have -4 and then minus 1/3, so it's going to be plus 1/3. So then that gives me 20 over 3 square units. So it's the area under the curve. So now we're going to do that for the line. So for under the line, we have, again, our limits are 3 and -1. The line function was 1 minus 2x dx. So if I integrate with respect to x there, I end up with x minus 2x squared over 2 between the limits of 3 and -1. So if I sub in for 3 there, I get 3, and then the 2 goes into 2 once. So I'll have -3 squared. And then my lower limit is -1. So simplifying that, I have 3 minus 9 minus -1 -1. And that gives me -6 plus 2, which is -4. Now, because this is a continuous piece, we're not getting absolute values here. So that's the important thing about this, right? So we're literally saying area 1 minus area 2 as you get it, okay? So area of shaded region, or the area enclosed, is 20 over 3 minus -4. Okay, so you can see normally if we were doing above and below the x-axis for 2 separate pieces, we would get the absolute values and add them. So in this case, we're using it as one continuous piece, so we're getting the area between the limits and subtracting our 2 answers. So 20 minus 3 plus 4 then is 10 and 2/3 square units. And as I said, you can do it out the longer way and get all your different limits and then getting the pieces shaded and adding them together. But this is a much quicker, easier way of doing it, okay? So if you go to your revision sheet, you're going to do question 46 on the revision sheet, which is one continuous piece. So here you can see in the question it says find the coordinates of A and B. So that's if you were to break it down into above and below the x-axis. And you'd end up having to subtract this bit away from the enclosed area here, okay? But what you can actually do is just get the limit. If I rub that out, you can actually just get the limits b and 0 and integrate under the line and integrate under the curve, and you would subtract under the line minus under the curve in this case. So see how you get on with that question. So it's just one question today.